Autonomous water supply, where part of the water supply system is an automatic water supply pump, or in other words a pumping station, is no longer a rarity. Let's see what a pumping station is, what components it consists of, and what you need to know in order to choose the right one for your needs. A pumping station is a system for automatic water supply assembled from various units. Automatic water supply pump can be a separate and finished product assembled into a single module, which remains to be connected to the water supply network. Also, the pumping station can be assembled into one system from elements of different manufacturers. The version, dimensions and characteristics may depend on specific requirements. For the most part, pumping stations are used in a country economy without a central water supply, where the source of water supply is its own well or well. The main task of the pumping station is the uninterrupted supply of water with stable pressure in the plumbing system. Constant pressure in the plumbing system is ensured by the operation of automation, pressure regulator, the operation of the pump itself, and the correctly selected volume of the hydraulic accumulator. The device and principle of operation of the pumping station. When the pumping station is turned on, an electric motor is started connected to an impeller with blades located in the pump housing. From the inlet hose, water begins to flow into the pumping chamber, where pressure is created, as a result of which water begins to accumulate in the accumulator. The hydraulic accumulator is a metal case with air preliminarily pumped into it under a certain pressure. A rubber membrane is located inside the case. The water pumped by the pump expands the membrane, and therefore, the water in the water supply system connected to the hydraulic tank is always under pressure. After the accumulator is filled with water, excess pressure is created in it. When a certain pressure threshold is reached, the pressure sensor turns off the electric pump. As soon as the pressure in the tank drops, the tap is turned on, the pressure sensor starts the pump again, and the membrane pushes the water out under the action of air pressure. What is a pumping station? Electric motor, pump housing, hydraulic accumulator, pressure sensor and automation. How pumping stations can differ from each other. Motor power, measured in watts. The power spread of household pumps ranges on average from 200 to 1.500 W. Performance is the next important metric, but one must always remember that performance is not always proportional to power. Productivity is measured in cubic meters per hour and can depend on many factors: engine power, the shape and width of the impeller with blades, the diameter of the inlet and outlet pipes, etc. The performance of domestic station pumps can vary from 2,000 to 6,000 liters per hour. But you should always remember that the indicated figure in the pump passport is the maximum. Height of water rise, head. If your house has several floors, then you need to take into account the height of the water rise to the upper consumer. Otherwise, the station that is not suitable in terms of parameters will simply not be able to supply water to the required height. It should be understood that these figures are approximate, since many factors must be taken into account, ranging from the diameter and material of the pipes to the number of fittings, pipeline bends, and the number of end users able to work simultaneously without much loss in pressure. With the figures for the height of the water lift indicated in the pump passport, you need to have an understanding, since the indicated lift height is most likely true, but provided that the water supply is of a suitable diameter, and the water intake and the pump are installed in the same plane and in the water main, between the pump and the upper consumer, there is no water consumption. And if, for example, the pump passport indicates a lifting height of 30 meters and all the rules for connecting it to a water intake are followed, then most likely the station will raise water by these 30 meters. But further, the rise of water will simply stop, and opening the tap at this mark, water will not even pour out of it. As in other things, in a couple of meters below, the water from the tap will flow barely, almost without pressure. The height of the water lift by the pump can also be taken into account as an indicator of the length of the horizontal pumping of water, given that an indicator of 1 meter of lift along a vertical water supply is approximately equal to 10 meters in a situation with pumping water through a horizontal pipe. Hydraulic accumulator volume. The number of consumers connected to the system and how often the pump will turn on depends on the volume of the accumulator. A station with a minimum volume of a storage tank will be able to provide the necessary water pressure for only 1 to 2 consumers. Remember that the volume of the hydraulic accumulator indicated in the passport is not used entirely. Therefore, in order to avoid frequent switching on of the pump and a quick loss of water pressure in the tap, the volume of the hydraulic tank should be selected with a margin, taking into account the planned maximum water flow in liters per minute. Also, you should not forget that the pumping station becomes inoperable during power outages, and on the volume of the hydraulic tank, it depends, albeit inconsistent, but still some time of autonomous water supply to consumers. Pump suction depth. This is the depth from which the pumping station can actually lift water in its normal mode. It must be remembered that even if the suction hose is horizontal, the suction capacity of the pump decreases as the length of the hose increases. And also, it must be taken into account that if the pump has a lifting height of, for example, 51 meters, and a suction depth of 9 meters, and it must take water from this depth, then the lifting height will decrease by these 9 meters. Now let's talk about the functionality of the pumping station and additional useful devices. Ejector. Some pumping stations can be equipped with an ejector, a device that allows the pump to be self-priming and a greater depth of water intake. The ejector can be internal, located in the station housing, and external. The internal ejector does not give such an increase in suction depth compared to the external one. The essence of the ejector is that when the station sucks water from a reservoir, part of the water is fed back through the recirculation hose to the ejector nozzle, where a rarefaction effect is created, due to which the suction water flow is accelerated. Also, it is worth noting that stations with an internal ejector are quite noisy. Pump protection against dry running. Protection stops the pump if water stops flowing into the pump. This feature will never be superfluous, especially when considering the cost of repairing or buying a new pump that burned out because the water suddenly ran out. Dry running protection is not installed on all models and is mainly present on more expensive versions of pumping stations. But do not be upset, it can be much easier to buy a suitable model of a pumping station without this function, and in addition to it, purchase a separate dry running protection unit. In principle, it can turn out even cheaper. Housing of the electric pump. Pump casings are most often produced in 3 versions: metal body, stainless steel, cast iron, plastic. According to many users of pumping stations, stainless steel housing is the most preferable. Such a case is less prone to cracking both during accidental impact and at short-term low temperatures, it does not rust, and the thread on the metal case has a greater margin of safety. Cast iron is afraid of frost, and after a long period of inactivity, rust can form in the pump housing. Plastic is not afraid of corrosion, but it sins by turning the threads. The threads of the drain and filler plugs become unusable especially quickly. The plastic is afraid of shocks and short-term frosts. How to choose the right pumping station for your needs. When choosing a pumping station, you need to be interested not only in power or performance separately, but also in the height of the intake and rise of water. When purchasing a pumping station, you need to clearly know your requirements and parameters, such as distance from the proposed installation site of the station to the water source and the height to the water surface plus horizontal length. The height of the required maximum level of water rise plus the length of the horizontal water pipe. Number of water consumers with approximate volumes of consumption. The diameter of the water supply, since it should be understood that if the diameter of the pipes is less than the diameter of the inlet and outlet pipes, this will reduce the performance of the station. You can select the required performance of the pumping station using approximate water consumption data for different devices. Approximate water consumption of different consumers included mixer in the bathroom 10 to 15 liters per minute. A set of water in the bathroom 10 to 15 liters per minute. Included shower 7 to 10 liters per minute. Washing machine 10 liters per minute. Dishwasher 5 to 10 liters per minute. Toilet flush 3 to 6 liters per minute. Summing up the required number of consumers, we get the peak water consumption in lira per minute, and multiplying this figure by 60 minutes, we find out the peak water consumption per hour. Now imagine that you have the following consumers. Faucet in the bathroom 10 to 15 liters per minute. Washing machine 10 liters per minute. Flush in the toilet 3 to 6 liters per minute. We get, at maximum flow rates of 31 liters per minute, this is peak consumption. We multiply it by 60 minutes and get the required performance. For a minimum supply of these consumers, we need a pump with a capacity of 1860 liters per hour. It must be understood that for the normal operation of these consumers, a pumping station with a capacity above this indicator is required, provided that the lifting height and suction depth do not exceed, but are much lower than the critical figures indicated in the technical passport for the pumping station. It is clear that this calculation is very rough and approximate, since in any case it is necessary to accurately take into account the depth to the water surface, the height of the rise, as well as the horizontal distances of the water supply and the internal diameter of the water supply, on which the outlet pressure strongly depends. Since the technical characteristics of pumping stations can vary significantly from each other, the final calculations should be made by specialists in a company store selling pumping equipment. But for this, you must be prepared and have all the necessary data. That's all. Let me wish you good luck and see you soon.